Good morning. So today we're going to talk about exponential functions. Exponential functions are a function in the form of y equals b, so some number raised to an exponent. Or, remember we talked about function notation, so it could have been f of x is equal to b raised to the x power. So some number raised to an exponent. Okay? Alright, so to graph an exponential function, you'll just plug in values for your x. Okay? You'll plug in values for your x and you will solve for your y variable. Okay? Alright, so if your exponent, or if your base, so your b, if it's greater than 1, okay, then we will have a exponential growth. Okay, and if b is less than 1, then you will have a exponential decay. Okay? So another thing with a exponential function is something that's called an asymptote. Okay, so it's a line where the graph gets so close to it, but it never touches it. Okay, so we're going to talk about a lot of ways to graph your exponential functions, okay? We're going to go through a bunch of examples here. Okay, so for this one, we've got f of x equals 4 raised to the x power. Okay, so what is our base here? Okay, our base is going to be a 4, right? So 4 is greater than 1. So this is going to be a growth. Okay? You'll have a growth here because your b is greater than 1. Domain here. To help you graph, remember your domain is your x values. Okay? Remember your range is your y values. Okay, so to graph, I can plug in anything I want to for this problem, right? There's no restrictions on my domain here. I can plug in everything, all real numbers, so from negative infinity to positive infinity. Okay, so you could say negative infinity to positive infinity. Alright, so let's do that now. Alrighty, so if I want to graph, I create a table here. You plug in some x values and you solve for your y value. Okay, so I don't know, let's plug in -2, -1, 0, 1, and a positive 2. Because we can plug in whatever we want to. That is a 1 right there. Sorry. Okay, so if I plug in a negative 2, so 4 raised to the negative 2 power, what does that represent? That represents actually 1 over 4 squared. Okay, so that's a really small number, so it's 0.0625. Okay, 4 raised to the negative first power, because we're plugging negative 1 in for our exponent. Okay, so that would be 4 raised to the negative first power. So remember, that would be like 1 over 4. Okay, which is what, 0.25? Okay, if you plug in a 0 for your exponent, so 4 raised to the 0 power, anything to the 0 power is always a what? A 1. Okay. 4 raised to the first power, so there's going to be a 4. And 4 raised to the second power, 4 squared, so that's going to be a 16. Okay, so when I graph this, okay, you're going to have a negative 2, and at negative 2, I'm barely going to be able to draw these, put a little dot, but it's going to be a negative 2, it's going to be a 0.0625. At negative 1, you're going to have a 0.25, so it's going to go up a little bit. At 0, you're going to be at 1. At 1, you're going to be at 4. And at 2, you're going to be up at 16. So it's going to be way up here somewhere. Okay, so this is a growth example here. Okay, it's an exponential growth, right? So it's increasing. Okay, so what's happening is that if I keep plugging in negative values for my x, if I keep plugging negative values in for that x right there, I'm going to get very close to this y equals 0 right here, to this. Okay, but I'm never going to touch it. There's never going to give me an example here that I'm going to get below that x-axis. Okay, so that is what's called an asymptote. It gets very, very close to that, but it's never going to touch it. Okay, so your asymptote here is going to be y equals 0. Okay, all right, so to graph here, that means that we'll kind of try to connect these dots a little bit. So I'm going to balance out here. I'm going to be so close to that line, but I'm not going to touch it. Okay. So my range here is going to be what? My range, remember, is your y values, so it's going to be all values that are greater than 0. So y is going to have to be greater than 0. And your y-intercept, we just found it right here. Your y-intercept is 0, 1. Okay. All right. Let's look at this one here. So, looking at this, what is my base? My base is a 1/3. Okay. So 1/3. Is that greater than 1? Nope. It's 1/3 less than 1. Then this is going to be a decay problem. Your domain, I can plug in all real numbers. So all reals. And that's not going to change. Okay. But we need to plug our problem in. We need to find our graph to be able to do the rest of the problem. Okay, so plug in -2, -1, 0, 1, 2. Okay, so if we say 1/3 raised to the -2 power, you can put that in your calculator. Or what does that mean? That would mean that 1 is going to be raised to the -2nd power and 3 is going to be raised to the -2nd power. So that means that this is actually going to be 3 squared. Okay, because remember what the rules of exponents are? Here, let me show you again. So that would be like 1 raised to the -2nd power and 3 raised to the -2nd power. To make those positive, you would flip-flop those, right? So 3 squared over 1 squared, which is going to just be 9 over 1, which is just a 9. Okay? Alright, so let's look here. So let's plug in a -1. So if we change that and make it a -1. So same type of thing is going to happen. It's a negative exponent, so it's going to take the reciprocal, so it's just going to be a 3. Okay, if you plug in a 0, anything to the 0 power is always and always will be a 1. Okay, if you plug in a 1, so it's going to be a 1/3, right? And 1/3 is the decimal at 0.333. Just going to keep on going. If you plug in a 2 for your x, so it's going to be a 1/3 squared, which is a 1/9. And 1/9 is going to be, what, 0.111. Just keep repeating that. Okay? Alright, so this graph is going to get, no matter what I plug in there for x, okay, big, small numbers, because look, it's a decay problem, so the larger I get, the closer to what value am I going to get close to. So the larger x value, what is my y value that I'm going to get closer to? But I'm never going to touch it. So no matter what I plug in there for your x, my y value is going to be close and close to 0, but never touch it. So your asymptote is going to be y equals 0. Okay, your y-intercept, you found it right there, it's going to be 0, comma 1. So remember, your y-intercept is always when x is 0. Okay, and so the range here is going to be all y values that are greater than 0. So your y value is going to be greater than 0. Okay, so -2, go up to 9. So -2 up to 9, sorry, I'm trying to, and then -1 up to 3, 0, 1, 1, right there, and 2, very, very close to it. So your asymptote is still going to be at the y equals 0. Okay, so now I'm going to connect the dots here. Okay, so I'm going to connect, and I'm going to draw it where it never touches that y equals 0. Okay? Alright, let's do another one. Well, let's do this one here. Alright. Well, let's do this one. Okay. y equals 3x, so the 3 is greater than 1, so this is going to be a growth. Domain is all reals, always will be this. Okay, alright, so let's choose some x values. So -2, -1, 0. We always want to choose 0 there because that's going to be our y-intercept. Okay. Okay. So -2, if I plug in -2 in there, that's going to be what? 1/9. So this is going to be basically the flip-flop of the 1/3 one. So a -2 squared, or 3 to the -2 power is going to be 1/3 squared. So it's going to be what? 0.111. -1, so that's going to be a 1/3. So that's going to be a 0.333. If you plug in a 0, that's going to be a 1. If you plug in a 1, that's going to be a 3. If you plug in a 2, 3 squared is going to be a 9. Okay? Alright, so if I plot these points, okay, so -2, 1, it's going to be way down there, -1.3, whoops, sorry, let's make that a little smaller. So -2 up there, and then -1, okay, 0, we're going to be at 1, at 1 we will be at 3, and then at 2 we will be at 9, okay, so no matter as my my x values get smaller and smaller and smaller. Okay, so as my x values get smaller, my y values get smaller. Okay, my y values get smaller and smaller, and this is still going to be my y. My asymptote is going to be the y-axis here. Okay, so y equals 0. It's never going to get to that 0. There's nothing I can plug in for x that's going to give me a 0 there. Okay. So it's going to touch it very closely. Okay. So your y-intercept is going to be 0, 1, because you found it right there. And the range is going to be all values greater than 0. Okay, so now let's do this one here. So this one is y equals 3 to the x power plus a 1. Okay, so I'm still going to be, my base there is going to be a 3, so it's still going to be a growth. My domain is still always going to be all real numbers. Okay, so now let's plug in. So -2, -1, 0, 1, and 2. Okay, so now it's going to be a little bit different. Okay, so now if I plug in a -2, so it's going to be 3 raised to the -2nd power plus a 1. So it's going to be 1/9 plus a 1. So what is that? That would be a 10 over 9. So that's going to be what? A 1.111. Okay. So now, if you plug in a -1, okay, if you plug in a -1, so plus a 1, so it's going to be 1/3 plus a 1, so it's going to be 1.333. Okay. If you plug in a 0 here, okay, now watch this, it's not going to be, it's got something added to it now. So if you plug in a 0, 3 to the 0 power plus a 1. Anything to the 0 power is a 1. So this is going to be 1 plus a 1. So now that's going to be a 2. Okay, so now if you plug a 1 in there, 3 to the first power, so that's going to be 3 plus a 1, which is going to be a 4. And then if you plug in a 2, so that's going to be a 9 plus a 1, which is a 10. Okay, so now if we graph these, so negative 2, at negative 2, we're going to be at 1 point, very close there. At negative 1, we're going to be at 1.3. Sorry, I'm trying to make these, but it's hard. Okay, at 0, we're going to be at 2, so it shifted the graph up a little bit, right? Up. Shifted the graph up 1 unit. Okay, at 1, we're going to be at 4, and at 2, we're going to be at 10. Okay, so no matter what I plug in for x, okay, as my x values get smaller, right, my y values are still going to get very, very close to 1, but they're never going to touch 1, okay? They're going to get small and small and small and small all the way up to that 1, okay? So your asymptote here is going to be at y equals 1. Okay, so that means when you draw your graph here, it's going to get close and close and close, but it's never going to touch that. Okay, it's never going to touch it. So what is your y-intercept? You found it. It's 0, 2. And your range is going to be all y values greater than that asymptote of a 1. So y has to be greater than 1. Okay? Alright, so now I want you to finish your homework set, and you'll have a great day.